This is a continuation of a previous video. Sorry for that. This we are talking about a cost consideration. We are into the foundation models session. So in the cost considerations, cost plays a major role when deploying a rack system at scale. As I mentioned, commercial providers such as LLMs charge separately for input tokens processed in parallel during a single forward pass, and output tokens is like a more expensive because each token is generated sequentially while conditioning on all previous tokens. As a result, longer web rows answers can dominate total cost. How to choose in practice? When comparing models, compare within the same tier, not across tiers. And differences in price within a tier are usually small. Cost differences between tiers are often substantial. So, example comparison is like a GPT-5, Gemini 3 Pro, like a flagship tier, and GPT-5 Mini or Gemini 3 Flash is the efficient tier. Rule of thumb, like use the lowest tier model that consistently meet your accuracy and reasoning needs. Upgrade only when retrieval quality and prompt tuning are no longer sufficient. Show typical input tokens price ranges across model types as of January 2026. Ultra efficiency is like a input token, so you can see the list of different kind of cost I have shown here. Now, the practical model selection guidelines. So model selection is trade-off between cost, latency, and accuracy. That is the main thing. The goal is to use a smallest model that still meets the requirement for each step in your RAG pipeline. Start with latency constraints. Latency is often the most important constraint, especially for user facing systems. Real time chatbots need responses within seconds. Most users will not wait more than 10 seconds unless the answer provided is essentially value. For typical chatbot interaction where questions are straightforward, context size is a manageable, usually 3 to 4 retrieved chunks. Ultra efficiency or efficient models often provide a sufficient quality while responding much faster than our large models. In this case, more powerful models rarely deliver enough extra value to justify their high latency. When accuracy matters more than speed, some workloads can tolerate slower responses. Batch jobs may run for minutes or hours. Latency is less critical than correctness. For example, a pipeline that reviews complex constructs may justify using slower, more expensive reasoning models. Slightly better extraction or interpretation quality can prevent costly downstream errors. However, not all tasks require this level of sophistication. Simple extraction is like a construct parties, dates, or identifiers, straightforward classification tasks. These are typical handled well by cost efficient models. Avoid overusing large models. Large reasoning models are powerful but expensive. Do not use them for simple classification, basic extraction, tasks that efficient models already handle reliably. Instead, test your pipeline at multiple model types. You may find ultra efficiency models work for 80% of queries. So, more expensive models are only needed for ambiguous or complex cases. This type approach reduce cost while maintaining over system quality. What is the key takeaway from this explanation? Like a default to smaller, faster models. Like a upgrade only when latency is acceptable and the accuracy gains clearly justify the added cost. The next one is that generating content using OpenAPI. So here, to create your Open API key, you need to log into the Open API website and generate your key. The steps are already available in previous videos in my channel. You can go through and get it back. And now I will discuss about that. Open API, how we can use Open API key in the RAG system, and how we can use a retrieval augmented generation. So the main two parts is like a retrieval and generation. You want to analyze and generate content using powerful large language models, but you do not want to deploy, host, or operate models yourself. Managing infrastructure for large models requires specialized hardware, ongoing maintenance, and scaling and reliability work. For most applications, this overhead is unnecessary. So the solution we can go with like OpenAI hosts it languages a language model on fully managed infrastructure and expose them through simple API endpoints. So this allows you to use a state-of-art model immediately and avoid infrastructure and operational complexity, and scale up uses up and down as needed. OpenAPI OpenAI model families. OpenAI provides multiple model families optimized for different task profiles, like a flagship model such as GPT-5, designed for complex reasoning and analysis, best suited for demanding tasks and high accuracy requirement, and a smaller, faster, and variant. So GPT-5 Mini and GPT-5 Nano is optimized for lower latency and lower cost, ideal for everyday or high throughput workloads. All of these models support multimodal input, meaning they can process text, image, and generate high quality responses based on that input. OpenAI hosted models let you focus on building applications when OpenAI handle model serving, scaling, and reliability behind the scenes. So these are like a complete theoretical explanation of foundation models, and I will go walk through the code in next session or next video. Thank you.